First formula, definitely got to know down cold. Distance, you know the three I'm going to put here. Distance, midpoint, slope, which I believe are all on unit 1. All right, I don't know if I put the slope ones on unit 1. All right. Distance, midpoint, slope. And the fourth one I came up with was, maybe you guys know what this one is, 180 times n minus 2. What's that for? Sum of the interior angles of any polygon. Are there any? I don't know. Those are the 4 I thought of that I'd like to write down on an index card. Any others? On the reference sheet, so don't worry about it. Don't waste your time. It's going to be on the reference sheet. Anything else? If you do, let me know during the course of today. All right, properties. What should you know the properties of? Definitely a parallelogram and all the family members, which would be rectangle, rhombus, I'd write square down, but okay, I'll write it down. Remember, that's all the properties of here. All right, all the properties. And the only other one I'd make sure you know all about is the isosceles trapezoid. Notice I didn't put kite up here because I don't want to waste your time. Okay? There's 6 units you have to plow through here and know down pat in the next week. I'm not going to put extra stuff you don't need. Trust me. All right, so those are really the properties to know for those figures. And I'll tell you, there's a good amount, guys. All right, straight up, there's a good amount of algebra problems with rectangle, rhombus. All right, making sure you know what the diagonals do, and maybe Pythagorean theorem for the rhombus. All right, rectangle, the diagonals create 4 isosceles triangles, so the angles across the congruent sides are congruent. All right, a lot of stuff on there, a lot of stuff. Okay, especially in the multiple choice free response section, part 1 and 2. Yes. What do you mean? It's got 3 sides. They add up at 280 degrees. What? 180. 180. Special vocab. These are terms I'd write down on an index card to make sure you know how they're formed and what's the special property. Circumcenter. And you know what's coming now? Anybody else want to chime in? Incenter. What else? Centroid. Yep. I'd put orthocenter down, but don't waste your time. Also, a little tip, can you construct them? I give you a triangle, construct the incenter. Can you do it? All right, that's what I'm talking about. All right, this is the level I'm talking about right now. How is it formed? You ready? How is it formed? Special fact. Can you construct it? Given a triangle. All right. And again, hey, you want to ask about one of these today, tomorrow, Friday? Feel free. That's what we're here for. All right. I won't construct it though, but I'll tell you how the steps to, what you would do to go about constructing it. That's all. These 2 are up on the YouTube channel Miss Venezia and I created. There's a link up on Aspen, all right, on how to construct all those. All right, anything else you want to add? Special vocab, those are the ones I definitely put on the sheet on my index cards. Also, just like I don't even know where to put this. Couple questions ask you to leave your answer in simplest radical form. So just in case you're a little shady on that part, simplest radical form, right? Couple questions ask you to leave your answer in simplest radical form. So breaking down a radical. Anything you want? Are we okay there? I thought that was a good way to start off class before you guys start asking your topics or questions. Quick review. Just so because I hate it when you guys waste your time asking questions during the exam. Part 1, bubble sheet. Bubble sheet. There you go. There's Maggie's bubble sheet right there. Bubble sheet. Part 1, fill it in pen. Bubble sheet. Part 2, right on the front of the booklet, there will be an answer. All right, blanks for answers. All right, part 2, all in pen, right at your answer. Both parts in 1 and 2, no partial credit. Remember, they're right or wrong. So I'm going to please take your time and make sure whatever the answer is, you bubble it correctly. And for part 2, you write the answer you want, because I am not going to search through part 2. I'm just going to look at the front page of your booklet and mark it right or wrong. Okay, so if you meant 12, write 12 and not 10. All right. Parts 3, 4, and 5, they go in the booklet. Yes, in pen. What's the only thing you can do in pencil? Graphs and constructions. Yes, please make sure, hopefully you'll be here tomorrow, but also your calculator's in class tomorrow, because I'm going to show you tomorrow and Friday, we're going to practice clearing the memory. All right, because I'm going to be up in front of Jim A saying all students clear your memory now, and I have 78 students taking a geometry midterm, and I don't have time like they do at the middle school. Right, that's what they do at the middle school. They individually come by and clear it. I don't have time for that. All right, I'm going to fly up and down the rows checking you cleared your memory. All right. All right, what do we got? Half hour, 34 minutes here, all your time right now, ladies and gentlemen, all your time. What would you like to go to, talk about, topics? Doesn't have to be questions, can be topics. Meg, you're up. Jasmine, you're on deck. Page 26, here we go. Bless you. This one? Okay, you got it.
So about the first one, I was able to prove the lines parallel.
Yep.
But I was having trouble with proving the angles.
Okay, PFB. Well, I got to highlight them so you can see them a little better. And QCE. Okay, and you just proved these lines parallel, right? That's a little off, but BF and CE, right? Okay, well, if I can consider PQ right here my transversal, do you know what type of angles those are? Are they on the same or the opposite sides of this transversal? Opposite sides, right? And they're outside. So these are alternate exterior. And if the lines are parallel, alternate exterior angles are congruent. So once you prove them parallel, those angles are congruent because parallel lines imply alternate exterior angles congruent. Okay? Jasmine, you're up.
So on page
49. I feel like this is going to be a tough one for me. All right, I'm all right with this one. Number 1, right? Okay. All right, here's the one vocabulary term I talked about today, centroid. Y is the centroid, PY is 8, TY is 18, FY is equal to AY plus 4. Okay, so I'll find AY in a second and find all those. All right, what's the special fact about a centroid? I'm going to go to know in next Tuesday. Splits the median into a ratio of 2 to 1, the part from the vertice to the midpoint. The vertices. So from T to Y is double the length of Y to I. All right. So if I have 18 for TY, what about YI? 9, half of it. If PY is 8, how about YA? Double it, 16. And we were also told that FY in the given was 4 more than AY, so FY should be 20. Meaning, what about GY? 10, yes. As far as the midterm goes, I wouldn't probably expect something as easy as this, but I would expect something like, hey, this is 5x minus 6, this is 3x plus 2, find the length of the entire median, TI. Okay, something like that, where what are you going to do with these two in an equation? And then, again, be disciplined. Once you find the variable, you need to be disciplined next Tuesday to go back and check, is that what I needed to solve for? Because most cases, the answer is no. You need to plug it back in to solve for something else. All right, be disciplined with that on next Tuesday. You find the variable does not mean you got the answer. You good, Jasmine? Next up, Maggie. Number 3. Okay, this one's a little crazy. This is a difficult one, I agree. You kind of had to look at number 2, I think, and the hint I gave you on number 2. But it's fine. All right, here we go. ABC is an equilateral. Okay, you guys start spitting out facts. What do I know about equilateral triangles? All sides are congruent and angles are congruent. Can you give me each angle measure if I needed it? What's each angle measure? How many degrees if it's equilateral and they're all the same? 60, 60, 60, yes. One side is 12, got it, meaning all sides are 12. G is the centroid, all right. Find AG, so I need to find this distance right there. I could make a better line than that. Okay, so find AG if that's the centroid. All right, so that's 12. Start filling in everything I know. Let's see, that's 12, yep. All right, let's see, where can I go from here? AG. Actually, can I just, I'm going to make it so it goes down. I don't like the way that looks. I'm just going to change my vertices. Not that what I had up there was incorrect. I just want to change stuff up. A, B, C. There we go. All right, ready, kiddos? If that's a centroid, what did I just draw in then? It's a median. Tell me something about a median. Vertice 2. Vertice 2. All right, everyone, I put 6 and 6. We're all good there. Okay. Congruent. What did you tell me about the angles? They're all congruent. These sides are congruent, right? Because it's equilateral. Anybody want to tell me anything about those two triangles I just created? They're congruent. We could go side, side, side. We could go side, angle, side. All right, everyone with me so far? Good so far? Okay, why is that good to know? Well, that means if these two triangles are congruent, what do I know about these angles here? They're congruent by CP/CTC, and they add to what? 180. So what do they have to be if they're congruent and add to 180? Right angles, 90 degrees. Everyone with me there? Why is that going to help to get to AG? Well, can you find the length of the median now? What can I do to find the length of the median? 6 squared plus b squared equals 12 squared. Pythagorean theorem. With me so far, Maggie? Good. Are we all right so far? All right, I have no idea. 36, 144. B squared equals, anybody, 144 minus 36? 108. Ooh, not pretty, huh? But hey, we'll get a little good opportunity to break down a radical here. 108 breaks down into 36, I think. Anybody want to check me on that? 36 and 3? I think so. I'm pretty confident. 36 and 3. Okay, so that's going to be 6 radical 3. That's the entire median. That's not AG, though. That's the entire median. But the centroid breaks it up into what? 2 to 1. Everyone agrees? So 2x plus x equals what? How long's the whole median? 6 radical 3. 3x equals 6 radical 3. What do you want to do on both sides? Divide by 3. What's this distance here, at least? X equals 2 radical 3. Not my answer, though. That's what x is. I was looking for AG, so I have to take 2 radical 3 and multiply it by 2. So that distance is 4 radical 3. Yeah, pretty involved. I'm not going to say it's not going to be that complicated. There's questions you're going to breeze through on Tuesday, and there's questions you're going to be like, whoa, I'll come back to that. All right. Maggie, all right? Anything else you want to ask additionally? I know that was a tough one. Good question. Thank you. Up the level in here. Next, anything? Going. Meg, Teddy on deck. Dewey in the hole. You sure? Yeah. Okay, here we go. Teddy. We can. Can you find one for me? I think they're in the 50s somewhere. Because we went over one yesterday in period 7. Your pick, your question, Teddy, so pick one to do, please. Eight? Okay, everyone, 8. By the way, how does everyone know this is an indirect proof? Because I may not say Tuesday, hi guys, prove indirectly. I may just say prove. How do I know this has to be done indirectly? Proving something is not happening, yes. Okay. Givens can go in. ABC is not isosceles. And BD is an altitude. Okay, after your givens, I need to put what for an indirect proof? My assumption. Where does the assumption, what are we going to assume is true? Opposite of the proof statement. Opposite of the proof statement. So we are going to assume that AD is in fact equal to DC. And remember, you can use that in the proof now as a given. Treat it as a given that AD is equal to DC. What are you trying to eventually do somewhere in your proof? Contradict a what? A given. How many givens do I have? 2. Which one do I probably want to contradict? All right, so sooner or later in my statements, I needed to say ABC is isosceles. Get me there. Get me there now. Get me to ABC being isosceles. I have 2 sides congruent. What's an altitude do? Forms right angles. Here we go. So I can say angle BDC and angle BDA are right angles. Not perpendicular lines form right angles here. You can write definition of an altitude, or you can write, hey, altitudes form right angles. That's fine. Then I probably need to say, because this is not going to be an HL one, I don't think. So I need to say, what about the right angles? They're congruent. If you end up doing an HL proof, yes, you don't need to say the right angles are congruent, but you do need to say they are right angles. BDC congruent to BDA. Right angles are congruent. Remember our goal, get it to be isosceles. You're on the hook now, ladies and gentlemen. Where do I go now to get this to be isosceles? Continue to be isosceles. I got a DB reflexive side. Yep, all right, let's keep going. Where are we going here? I don't know. I'm just following you guys. Excuse me? Prove the triangle's congruent. If that tilde comes out anywhere on your midterm, I don't know what you're doing. The only time it should come out is above the congruent side. That is it. Triangle ABD, congruent to triangle CBD. Got a reason? Make sure you're familiar with all 5 ways. All right, what's that? What good does that do to get at isosceles? Or if you didn't want to do angle A and angle C, you could do AB congruent to CB. Either one will make it isosceles, indeed. I'll just do the first one I heard there, angle A congruent to angle C. What's your reason either way? CPCTC. Now, if you have 2 angles or 2 sides congruent in a triangle, it makes it isosceles. So triangle ABC is isosceles. That's a problem. What's a good reason why it's isosceles? That's not what we're proving. I don't want to write assumption led to contradiction. I want to save that for what we're actually proving. Why is it isosceles? In a triangle, 2 congruent, in my case, angles, might be sides for yours. 2 congruent angles implies isosceles triangle. Yep. And then what do you notice we have right now? Between your given and what we just wrote, those are a contradiction, which means what about our assumption? It's wrong, it's false, meaning the opposite. AD not equal to DC is true. That is where we write assumption led to a contradiction. And as I don't know if we remember or not, you do need to write the statement numbers where the contradiction occurred. So it was in our givens and step 8 where you contradicted yourself. Teddy, we all right? Anything you want to ask there? Okay, you know there's 3 proofs on there, and I showed you the 5 that it could be yesterday. All right, indirect being one of the choices. Dewey, you're up. Orion in the hole, or on deck. Page 50, number 5. Yep. Okay, before I do anything, I need probably all the angle measurements from you. All right, so can you please find all the remaining angle measures so we can figure this one out? Anybody have LMO? 30, 38? Anybody have angle N? Okay, before I start this, if I'm going to label them from, what is it, shortest to longest, what is the theorem that's going to help me here? What's the theorem? Before I even apply it yet, what's the theorem I need here? Grace? In a triangle, longest side across from longest angle, or you could say shortest side across from smallest angle. All right, that's where we're going here. But unfortunately, you just can't pick the smallest angle, which in this case is 38, and that is the shortest side. I don't know that. All right, so what I recommend you do before you start this process is take each triangle separately, MLO and triangle MNO, And for each of those triangles, write their sides from shortest to longest. All right, so let's start with MLO. What's the shortest side in MLO? LO followed by LM. And the biggest side is the hypotenuse, MO. And other triangle, MNO, what's the smallest side? MO, that might be a problem. All right, next one. MN, followed by ON, yep. All right, we ready to put these suckers in order? Okay, shortest side. Well, it's a debate between LO and MO. It's got to be one of those two because they're the shortest sides in the triangles. There's a problem with one of them, though. It can't be what? Why can it not be MO? Because there's two sides shorter than that here. So what's the shortest side overall? LO. All right, now it's between MO and LM. It's got to be LM because look, we wrote that LM is shorter than MO, right? So LM, sorry. So it's got to be LM. All right, what am I down to now? It's got to be MO. And we are all right going from here. Next one, MN, followed by the largest side in the diagram, ON. There we go.
Would we just do the same thing, same process for number 4 and the figure on the right with the second is the shortest?
Correct. Mm-hmm. Orion, you're up, sir. Coordinate proofs. Did I put any in there?
Yeah, on page 75.
75. Going deep. Ooh, isosceles right triangle. You want to do 29 instead? Sure. Your call, Ryan. That's fine with me. Prove Fred's a rectangle? You got it. Guys are coming up with some great questions today. All right, here we go. 1, 2, 3, point F. 1, 2, 3, 4. Whoops. 1, 2, 3, 4. 1, 2, 3, 4, 5. It's R. 1, 2, 3, 4, 5. 1, 2, 3. Is E. And D. 1, 1. All right, sorry about my lines there, but all right, let's prove Fred's a rectangle. A lot of different ways. Okay, you could, let me just write down the different ways and then we'll pick one. I could show it has 4 right angles. I could show it's a parallelogram with what, ladies and gentlemen, while we're here? 1 right angle. Or I could show it a parallelogram with, what's so special about the diagonals of a rectangle? Congruent diagonals. Do we have a preference as a class? 4 right angles, I'm assuming. That's where most of you would take on. Yes, no, maybe? Okay, so what formula am I going to need then? Slope. All right, so everybody, let's find the slope of FD. Let's find the slope of FR. Let's find the slope of RE and the slope of DE. Now you do not, because we did graph it, I'm not expecting you to use the slope formula. You can if you want. If you use rise over run, that's perfectly acceptable. All right, so go ahead and find the slopes for all four sides. All right, so FD, what are we getting for the slope of FD? Up 2 over 1, -2? How's that look? FD, -2. Good? All right, let's go FR, up 2 over 1, 2, 3, 4, so 1/2 for FR. Up to -2 for RE. And I'm probably going to predict DE to be 1/2, up 2 over 4, yep. Okay, everyone good with the slopes? All right, step 2, what did we just prove? Not right angles. Okay, here we go. Let's list them all out. We just proved FD is perpendicular to DE. We also proved FD was perpendicular to FR. I got to write them all out here. Yeah, let's see. FR is perpendicular to RE. RE is perpendicular to ED. I think that's it, right? Did I miss any? ED and FD I already put there. Why? Because slopes are negative reciprocals. Okay, so what do perpendicular lines form? Right angles, so angle F, angle R, angle E, and angle D are right angles because perpendicular lines form right angles. And then now what is it? Fred is a rectangle because it has 4 right angles. Okay. We all right there, Ryan? Maggie, what's up?
We don't have to prove that it's a parallel.
If you're going to do it this way, no.
Okay.
Because the only quadrilateral out there that has 4 right angles is a rectangle and a square. So once it's got 4 right angles, it's automatically a rectangle. Yep. Anything else? Hi, Paige.
How can we prove it if we had to prove it was a square
After this, after you've proved 4 right angles, you would need to prove 2 consecutive sides congruent. That's all. You don't need to prove all 4 sides. 2 consecutive sides congruent. So what formula would I need there? Distance formula. Yep, if I needed to put that into a square. Yep. Good question. Or not a square for that matter. Or not a rhombus if I asked after that. Connor. Perpendicular diagonals would be another way. Yep. Do a rhombus property, basically. Yep. Anything else? Yes. You can do that, yes. That's totally acceptable. Yep. Anything else? Good questions today, real good questions. Hi, Meg, I'm ready.
What is
Skew?
skew?
Somebody asked that question yesterday, so hold up my plane. 2 lines, and I know this sounds strange, and it sounded strange when I introduced it to you. 2 skew lines are not parallel and do not intersect. Think about that one. Not parallel and do not intersect. That's why it's got to be three-dimensional. Ready? Here's one line. Hold it up. Get that up there. Get that arm up there. No, don't. Get your arm up there. There we go. Here's one line. Second line. There, right? Three-dimensionally. One's on the bottom here. Okay? All right, and I couldn't draw it two-dimensionally. It had to be three-dimensionally. Okay? Others, yes. An HL proof. Whew, all right. Bless you. Well, I'm going to have to do something I haven't done in a while, is just make one up off the fly. Hey, I'm giving you everything, but I have no other choice right now. So I'm just making this up. But here you go. Here would be an HL proof. Actually, you know what? I'm not going to give you that. Make it a little tough, at least somewhat tough. I'll just give you A, C, and BD. Okay, so these two triangles. Oh, by the way, now that I've busted this out, yes, you can also bring markers, colored pencils, highlighters if you want. That's fine. Totally acceptable if you want to add that to your supply list. That's a you call, though. That's not required. The pencils, pens, calculator, compass, those are required. All right. All right, so let's go over this one here. Hopefully we can get this done here in the next 2 minutes, 15 seconds. Well, first of all, why is it going to be an HL proof? HL is reserved for what type of triangles? Okay, and the perpendicular lines tell me you have right triangles in BAD and CAD. So you do need to state that those are right angles. Perpendicular lines form right angles. You do not need to tell me they're congruent, though. If you do, it's still fine. All right, but in an HL proof, you do not need to tell me they're congruent. Everyone see I showed you AC and BD. Those are the what in the right triangles? AC and BD. Those are the what in each right triangle? Those are the hypotenusae, hypotenuses, however you say it. So there's the H part. Where's the leg going to come into play? Where's the leg, though? AD. Everyone see reflexive side AD? All right. Now, the one thing you may forget about, because it's been a while since we've done them, before you say the triangles are congruent by HL, obviously, yes, you need to say AD congruent to AD. You need to tell me the right angles. But before you write down they're congruent by HL, you need to tell me that they are right triangles. So before you say HL, you need to say triangle BAD and triangle CAD are right triangles. Anybody remember the reason I would put in? Right triangles have right angles. And then you could say HL. Don't forget about it. Everyone forgets about that fifth method, HL. After school all this week, Saturday, 12 to 3, first review session. Business trip, not a social trip.